My name is Cormac Murchu. I'm currently doing a structural engineering master's here in CIT. I'm going to talk about how maths are applicable in the engineering in the work we do. So it started off in first year where we learned about matrices and vectors, and at the time we didn't know why we were learning these or what they were because they weren't covered in the Leaving Cert. As we progressed on through the course, we realised how applicable they were. In third year then, we kind of developed it further and we learned about something called eigenvalues, which allowed us to solve non-zero solutions for matrices and vectors, which allows us then to analyse and solve things like buckling. Later on then, when we got to fourth year, when we got into the more advanced kind of structural analysis, we learned about something called the stiffness matrix. And the stiffness matrix essentially allows you to solve beams, columns, any element that are statically indeterminate, which means they're very complex or more complex than your simple supported beam. So we learned how to solve them and solve all the members associated with them, and as well as that, all the structure analysis software packages use the stiffness matrix to solve the beams as well. So it uses an iterative process and runs through the stiffness matrix, and that's how it all comes out. And essentially it's very important as a student engineer to know how these matrices are applicable and how they allow the software to work as they do. And it's important to be able to do them by hand as well. Another use for the stiffness matrix is when doing dynamic analysis. So what dynamic analysis means in terms of structural engineering is earthquakes, seismic loading, where you find out the natural frequency of your building subject, so it starts oscillating at its own natural harmonic frequency. The way you solve it is by setting up a stiffness matrix of second order differential equations, and from that you can find your inverse and your transpose, and in the end you solve a determinant of these differential equations to again solve your building and design accordingly. In engineering, when you're setting up your stiffness matrix, you could have a wide variety of different types of stiffness matrix. You could have a 2x2 matrix for a simply supported beam, all the way up to an 11x11 matrix for a complex bridge or something like that. And that's where we like to get the computer to do the analysis for us.